Hello. We need to look at the coefficient of expansion of a liquid. The coefficient of volume expansion, gamma, is the fractional change in volume per unit temperature. So delta V is the change in the volume. V naught is the original volume. Delta theta is the change in temperature, and gamma is the coefficient of volume expansion. So this is the coefficient of volume expansion, this is the original volume, and this is the temperature change. Now this is not in the data booklet, I don't believe, so you need to know that. But it's fairly straightforward. It is fairly straightforward. So what we need to do is look at an example of this. We have what is a volume expansion. We look at an example of this. If the volume expansion coefficient is 2 times 10 to the negative 4, if the mass of water is 2 meters deep and there's an area of 40 meters squared, what is the new water level with a 2-degree increase in temperature? Well, delta V is equal to gamma V naught delta theta. Gamma is 2 times 10 to the minus 4. V naught is the volume, which is 40 meters squared, times by 2 meters, times by 2 because it's a temperature change of 2 degrees. This gives a value of 0.032. This is a change of volume. This should be meters cubed, by the way. So the new volume is going to be the original volume, which is 80, plus 0.032, which is going to be 80.032. This is a volume. Now we want to find just the height, the new height. Let's say that the sides of this container are vertical, so the area is not going to change. So we just divided by the volume by the area to get the height, and we end up with 2.0008 meters. This is a raise by 0.8 millimeters, which is a tiny change in the height. Now, on a global basis, this tiny percentage height change can be quite considerable. Let's say the Earth is 2/3 covered with water. The average depth is, let's say, 4,000 meters. The radius of the Earth is 6,400 kilometers. Find the volume of the water on the Earth. Well, if you know the radius of the Earth, you can basically find the area of the Earth. We multiply the area by the depth. That gives you the volume of the water. Let's say that the Earth's temperature rises by 1 degree centigrade. What will happen? So you find the volume of the water on the Earth, which is basically the area of the Earth, 4 pi r squared, times by the depth. What are the assumptions? We're assuming that when the water expands, it just expands in a vertical direction. It's not going to spread out sideways. Of course, when it goes onto land, it will spread sideways. Another assumption is that we are assuming that all the water is heated by 1 degree. If the surface water increases by 1 degree, deep in the water, the temperature change will be much smaller. So this will give a smaller value for the new height. But let's do this the calculation anyway. Delta V is equal to gamma V naught delta theta. Now, gamma is 2 times 10 to the minus 4. The volume is the area of the Earth times by the height. So it's 4 pi r squared, which is where r is the radius of the Earth, times by 4,000 meters, times by 2/3, because it's 2/3 of the Earth is water, times by 1, which is a temperature change of 1 degree. So we multiply these together, and we end up with a change in volume of 6.8629, and so on, times 10 to the 10 meters cubed. So this is going to be the change in volume. So what is the new volume going to be? It's going to be this original volume plus this change, and you will get a new value which is 3.43214.229 times 10 to the 14 meters squared. Now you have to basically, here again, divide by the area of the Earth times by 2/3 and find a new value for the height, and it will be slightly greater than 4,000 meters. But how much greater? We can do it in a simpler way. Let's assume that it's just going to be a vertical change in the volume of water. So it just increases vertically by a factor of gamma delta theta. So remember again, 2/3 of the Earth is water, average depth is 4,000 meters, radius of the Earth is this. Find the volume of the water on the Earth, and it goes up by 1 degree. So this is equation delta V is equal to gamma V naught delta theta, where gamma is 2 times 10 to the minus 4. So the original height is 4,000 meters. Let's just treat the volume as a cuboid, x, y, z, where y is the height. So it's going to be y, okay, excuse me, this should be y times by xz naught, not y times by xyz naught, times by delta. Okay, this is going to be the change in volume is equal to gamma times by xyz naught, which is the volume, the original volume, times delta theta. Let's divide by y and z. So delta x, which is the change in height, is going to be gamma times by x naught delta theta. We can do this because we're assuming that that yz is going to stay constant. We're assuming that yz is going to be constant. In other words, the area is going to stay constant. So we have a 2 times 10 to the minus 4 times by 4,000 meters times by 1 degree, and we get a change in x of 80 centimeters. Now this is quite a considerable rise in the surface. This is quite a considerable rise in the water level. There are implications of flooding and so on. State that one possible effect of the enhanced greenhouse effect is a rise in the mean sea level. So, students should be aware that precise predictions are difficult to make due to factors such as the anomalous expansion of water. It doesn't expand vertically. It doesn't expand like this. What is basically going to happen is that when this is the level that it would do if it just expanded vertically, but of course this part over land is not being filled. A more realistic version is that when it expands, it will expand to somewhere like this. A more realistic expansion would be that when it expands, it won't go so high because it's spreading out sideways as well. So the height will be less. So the rise and the temperature give an increase in volume. However, the water spreads over a larger area, so the change in height will not be as extreme. State that one possible effect of the enhanced greenhouse effect is a rise in the mean sea level. Here again, we need to compare ice, which is melting. We need to compare ice, which is melting on land, with the ice, which is melting in the sea. This is the ice that is melting on land. The ice is held above the sea level. When it melts, it will add to the volume of water which rises, so the volume of water will increase as the ice melts. This is in the case of ice that's on land or glaciers and so on. However, what happens with icebergs, ice that's already in the sea? What we have here is that this ice is taking up a certain volume of the water already, and when it melts, this ice will reduce its volume, so basically the sea level will stay exactly the same when it melts. It's got more volume now, but when it actually melts, it will reduce, and for one reason or another, it will basically fill exactly the same volume and what will happen is that when the ice melts, the water level will be precisely the same. So ice melting on sea does not directly change the water level, because the ice already adds volume to the sea. So outline possible reasons for predicted rise in sea level. So why do we have a rise in sea level? One is the rise in temperature. When the temperature of the water rises, it expands. Another one is the melting of glaciers or land ice. The water will run into the sea, and therefore the sea level rises. Note that the melting of icebergs does not contribute to the rise in sea level.